welcome to physics class with me, Miss Rani.
How are you feeling today? I hope you are in a good feeling and ready to learn physics. Today, we are going to talk about condition for equilibrium. Let's check the simulation. We have a seesaw. It is a long beam, rigid object that is pivoted at a point. We can try to put a boy with a mass 20 kg sitting on the left hand end of a seesaw. His weight causes the seesaw to tip down on the left. Now, if we try to put his father with mass 80 kg sitting on the other end, what will happen? The seesaw will tip to the right and he will come up in the air. Now, we can move the father sitting closer to the pivot. And the seesaw is to be balanced. When a beam is balanced, we say that it is in equilibrium. If an object is in equilibrium, the force on it must be balanced. It means that no resultant force. And also, the turning effect of the force on it must also be balanced. It means that no resultant turning effect. If a resultant force acts on an object, it will start to move up in the direction of the resultant force. If there is a resultant turning effect, it will start to rotate. So, the condition of equilibrium will happen if both resultant force and resultant turning effect equal 0.
Let's us analyze the equilibrium condition for this seesaw. The mass from the boy and father produce the force downward called weight. We can calculate their weight using this equation. Weight equal mass multiplied by gravity. Suppose that the gravity is 10 meters per second square, so the weight for the boy is 20 kg multiplied by 10 meters per second square. It's equal to 100 Newton. And the weight for his father is 80 kg multiplied by 10 meters per second square equal 800 Newton. The weight of the boy on the left is tending to turn the seesaw anti-clockwise. It means the weight of the boy on the left has an anti-clockwise moment. The weight of his father on the right have clockwise moments. Suppose that the distance is measured in meter, so the distance of the boy to the pivot is 8 meters, and the distance of his father to the pivot is 2 meters. We can calculate this moment is the total anti-clockwise moment equal 200 newtons times 8 meter, it's equal 1600 Newton meter. And the total of clockwise moment equal 800 Newton times 2 meter, it's equal 1600 Newton meter. We can see that the total clockwise moment is equal the total of anti-clockwise moment. So the seesaw is balanced. In the drawing of the two people on the seesaw, two forces are shown acting downwards. There is also the weight of the seesaw itself. It's 250 Newton, which also act downward through its midpoint. If there was the only force acting, we would make the seesaw accelerated downward. Another force acts to prevent this from happening. There is an upward contact force where the seesaw sits on the pivot. Because the seesaw is in equilibrium, we can calculate this contact force. It must balance the three downward forces, so its value is 200 Newton plus 800 Newton plus 250 Newton. It's equal 1250 Newtons upward. This force has no turning effect because it's acts through the pivot. Its distance from the pivot is 0, so its moment is 0. Now, we can satisfy the two conditions that must be met if an object is to be in equilibrium. First, there must be no resultant force acting on it. And the second, the total clockwise moment must be equal to the total anti-clockwise moment. You can use these two rules to solve problems concerning the forces acting on objects in equilibrium. Calculate the unknown force A and B for the balance beam shown. First, let's analyze the turning effect caused by each force. Force 250 newtons will cause the beam rotate in anti-clockwise direction. Force B will cause the beam rotate in clockwise direction. And force A has no turning effect because it's acts through the pivot. The beam is balanced, so the total turning effect in anti-clockwise must be equal to the total turning effect in clockwise direction. Since the turning effect is force multiplied by distance of the force to the pivot, so 250 Newton multiplied by 4 meter equal force B multiplied by 5 meter. It will be 1000 Newton meter equal force B times 5 meter. So force B can be calculated by 1000 Newton meter divided by 5 meter. Force B equal 200 Newton. Then, to calculate the force A, let's analyze the resultants of force. We can see that there have one force goes to upward and two forces go to downward. Since the beam is in equilibrium, so the total of upward force must be equal by the total of downward force. Means that force A must be equal by 250 Newton plus 200 Newton. So the force A is equal 450 Newton. Thank you for watching this video. I hope that you will understand about this topic and see you in the next video. Bye-bye.